Hello, so in this video I'm going to show you how to take the derivative of a product and a quotient. So one thing that we can do is look at how we can find the derivative, for example, of the following two functions. Like if we have 3 plus x multiplied by x, well, we might be tempted to say, like for example, if f of x is equal to 3 plus x, and g of x is equal to x, that we can actually just say that, f prime of x is equal to 1, and then g of prime of x is also equal to 1. But whenever we multiply that, that would imply that, okay, that f prime times g prime equals to 1. So it's like we're saying that the derivative of the two functions f and g equal to f prime times g prime of x. Okay, but this is actually not true. Why? Because say for example that we just go ahead and multiply. Okay, so if we go ahead and multiply, we'll have x squared plus 3x, which is actually just going to be equal to 2x plus 3, which is completely different than what we found when we used that the product of the two is just the product of the derivatives. So that's not actually true. Now, the way of which that we can find the derivative of a product, or any product for that matter, is by saying for any f of x and g of x, the derivative is given by, so we have the derivative of f of x times g of x. This is going to be equal to f prime of x times g of x, so g of x plus f of x times g prime of x. Now, this is what we call the product rule. Okay, so we have that this is our product rule, and this works as long as the two functions are both differentiable. So, for example, let's say that I want to find the derivative of x squared plus 1 multiplied by x plus 2. Now notice that this is very easy if we just multiply FOIL and then see what that is. But in this case, we're just going to say that we're going to look for the derivative of f of x and g of x multiplied. Okay, so this will be f and that'll be g. So the derivative of both f times g is equal to the derivative of x squared plus 1 multiplied by x plus 2 plus x squared plus 1 multiplied by the derivative of x plus 2. Okay, so this is actually not bad because all that I need to do is simplify. So I have that that's going to be 2x multiplied by x plus 2 plus x squared plus 1. So x squared plus 1, and then multiplied by 1. So this gives me the following. It gives me 2x squared plus 4x plus x squared plus 1. So it looks like basically we have 3x squared plus 4x plus 1. Now, okay, yeah, it seems that it would have been maybe easier if we just FOILed, but essentially this saves us the trouble of having to FOIL and then take the derivative term by term. Now, if I wanted to, I could also imply, like, for example, if we have that we want to find the tangent line, or for that matter, we can always just say the tangent slope. Oops. Okay, so we'll just say find the tangent line at x equals to 0 for, okay, so we have y equals to the square root of x plus 2 multiplied by x plus 1. Now, basically note that essentially you need an ordered pair in order to continue. So I know that I'm going to have to find y at 0. So I have the square root of 0 plus 2 multiplied by 0 plus 1. But that's really just going to give me 2. So essentially I have that this function passes through 0, 2. Now, what comes next is that I need to find the derivative of this equation. Now, I find y prime, and I'm going to use the f times g. So like this is f and that's g. So I have 1/2 multiplied by x to the negative 1/2, but multiplied by x plus 1. Okay, so this is going to give us plus the square root of x plus 2, and this is multiplied by 1 also. So what happens is that I end up with 1/2, and then I have x plus 1, but it's all divided by the square root of x. So we have that this is divided by the square root of x, and then we have plus, so we have, what is that? That's should be 1. Okay, so this should be 1 right here. Okay, so this is going to be the square root of x plus 2. Now there's a problem here. That problem is that if you plug in 0 into this equation, you have that when you plug in 0, it's actually going to be undefined. So we have undefined at x equals 0. So what that means is that there is no tangent line, unfortunately. Most likely it's because there's a vertical tangent. So we'll just say that the tangent line right, so the tangent line does not exist. Okay. Now, the other thing of which that we can look at, for example, is what we call the quotient rule. But before we get to the quotient rule, I'm going to look at something called the reciprocal rule. So the reciprocal rule is basically like if I take the derivative of a constant such as 1 divided by f of x. Now, of course, f of x must not be equal to 0. But here's what we get. We get that this is going to be equal to negative f prime of x all divided by f of x. But it's going to be squared. So we have negative f prime divided by f squared. Okay, now and again, this is provided that f of x is not equal to 0. Now, there is a way that we can apply the reciprocal rule. Okay, so such as like if we were to take the derivative of 1 divided by x squared plus 1, well, this is very easy because reciprocal rule says square the bottom and then just take the derivative on top of the denominator. So I have negative 2x divided by x squared plus 1, and then we just square that. Now note that basically there's a horizontal tangent for when x is equal to 0. So we have f prime of 0 is equal to 0, which is basically just a horizontal tangent. Now, if you were to basically graph that equation, you would find that it looks something like a bell curve, where it looks something like this. And then you would have that the function has a horizontal tangent at 0. So we have something like this. Okay. Now, we'll talk about like, for example, like there's a max right here. But for now, we're just kind of like practicing like how to find derivatives and whatnot. Now, the next thing that we finally can look at is what we call quotient rule. Now, quotient rule is basically just saying that if we take the derivative of two functions divided each other, like f and g, that's going to be f prime times g minus g prime. So we'll just put f times g prime divided by g squared. Now, in reality, you have that g cannot equal to 0 in order for this to work. Now, I wrote it a little differently than most traditionalists. So, for example, normally we'll say that f of x divided by g of x, and we take the derivative of that. Normally, we'll say something like this is equal to g prime times f of x. Let's write that again. Times f minus g prime times f. Not g prime, actually. Yeah, it's supposed to be g. So it's g times f prime, and then g prime times f. All of this is divided by g squared. Now, the reason that I wrote it both differently, kind of, but you can see that you can interchange it, is because basically there's a way to kind of memorize this, like high D low minus, wait, it's something like, yeah, it's like high D low, and then we have low D high or something like that. Um, yeah, so if you want, you can try to memorize it where you have that it's the low D high, and then it's supposed to be high D low. So in that case, that would mean that these two would have to be interchanged. But I mean, it's all the same really, so it's however you want to memorize it. Now, the way that you can actually prove it though is the following. You have f times 1 over g, and accordingly you can use a form of product rule and reciprocal rule, which says f prime times 1 over g plus f times negative g prime divided by g squared. So what this means is that you have um, g times f prime divided by g. I just use common denominator. And then I have plus negative g prime times f divided by g squared. This should be squared also, yeah. So basically I see that essentially I have the formula using product rule and reciprocal rule. So this will be, yeah, minus g prime times f, and then all of this is divided by g squared. Okay, now the thing that you need to do though is to really practice this. So for example, if I want to find the derivative of, say for example, x squared divided by 1 plus x squared, well, this is equal to, okay, so we have x squared plus 1 to the second, then we have x squared plus 1 multiplied by 2x minus, well, the derivative of the denominator is also 2x, so that's going to be 2x times x squared. So this actually reduces a little nicely. It reduces to, let's see, it reduces to 2x squared plus 2x minus, not 2x squared, 2x cubed minus 2x cubed also. So you'll notice that, yeah, some stuff does cancel out. So you have plus 1 and then that's squared. So we have that this cancels out and that cancels out. So that means that everything reduces down to 2x. So I have that this becomes 2x divided by x squared plus 1 to the second power. Now, this is one of those other equations that you have a horizontal tangent at 0, so just keep that in mind. Okay, and one last example. So let's say that we were trying to find the derivative of the following equation. So let's say that you have um, so let's say that you have x minus 1 divided by x plus 1. Okay, so essentially what we want to do here is find the derivative of this equation. Now, of course, you have that one of the functions is f and one of the functions is g. So in this case, like what you can do here is take apply the quotient rule. So you have that this is going to be the x plus 1 squared. Then you have the derivative of x plus 1, which is, we can write it how, x plus 1 multiplied by x minus 1. And then that's going to be minus, actually it's not the derivative of that, it's supposed to be x minus 1. Yeah, it's very easy to make a mistake with this if you don't have the formula down, which apparently I don't remember it. Okay, let's just rewrite it. Okay, so essentially I have x plus 1 to the second power, and then I have x plus 1 multiplied by 1 minus 1 from the derivative of x plus 1 multiplied by x plus, or no, x minus 1. Okay, so what this does is it gives me the following: x plus 1 minus x plus 1 all divided by x plus 1, and that's squared. Now all of this simplifies to 2 divided by x plus 1 to the second power. Now, one thing to note about this derivative is that it's always going to be positive, which basically means that there are no horizontal tangents. But you also have that it's undefined at -1, so that's one thing to remember, that this one does not have a horizontal tangent, but it's always increasing. Now, the one thing that I would recommend is trying to approach it from many different perspectives. So, for example, x minus 1 divided by x plus 1 is the same thing as, like if you were to do the long division, you would figure out that that's going to be 1 minus 2 over x plus 1. Now, notice that basically we have the answer. Why? Because if you're taking the derivative of 1 minus 2 over x plus 1, well, we know that the derivative of 1 is just 0. But then using reciprocal rule, we'll find that you'll end up with -2 times 1 divided by, and it's double negative, isn't it? Yeah, so it's negative divided by x plus 1 to the second power, which is still the same. It's still going to equal to positive 2 divided by x plus 1 to the second power. So there are many different ways that you can actually take the derivative of any function, okay? So like let me just leave a practice problem. So like for example, like if you take the derivative of x squared minus 1 all over x, you'd be tempted to use quotient rule. But note that you can actually rewrite this before you even start. So you have the derivative of x minus 1 over x. Why? Because I just separated it. So try this one then. And then, furthermore, you have that there isn't a way, well, let's say like this. Let's say that you want to find the derivative of the square root of x minus 1 over 2 times the square root of x multiplied by the square root of x plus 1 over 2 2 yeah 2 root x, or 1 divided by 2 root x. Now you might be tempted to actually multiply this, or no. You might be tempted to use product rule and a little bit of quotient rule, and then you're going to probably get lost in all the algebra. But note that, for example, a minus b times a plus b is equal to a squared minus b squared, which basically means that you can actually just rewrite this equation into the derivative of x minus 1 over 4x. Then from there, just figure out what the derivative is. So in that case, quotient rule, product rule doesn't help. We have to just kind of find the easiest possible way. Okay, so that's going to be it. And as we kind of proceed on, what's going to be kind of beneficial is that you know all the rules from 1 to 2, and then even in chapter 12.3. Okay, so it's going to require that you know a lot of the different derivatives.